Example 2, find the absolute value. So we had the absolute value of a plus bi equals the square root of a squared plus b squared. So we're just going to use a and b, we're not going to use the I. And it finds the distance from the origin to the complex point. So if we come back to what we just learned, it finds it from the origin to the point. So how far is it? Because we don't want to go from here to here, we want to know a straight distance. So we have our problem here. Example A. Absolute value of negative 9 plus I. We need to remember that there is a 1 right here. Okay, and that 1 is your b, so your a is your negative 9 and b is the 1. So we need to take our square root of negative 9 squared plus 1 squared. Either do it separately or all at once, it does not matter. But this does need to be in parentheses because of the negative. Negative 9 squared is 81. 1 squared is 1, so 81 plus 1 is 82. If we can, we need to take the square root of that. This one, it is not possible. B. This one is just the absolute value of 6. It is just the real part, so this is just A. You guys will probably know this anyways, but we're going to go ahead and work it out. So the square root of 6 squared plus, we have b. There is no b, right? So no b. So 0 squared. So 6 squared is 36. 0 squared is 0. 36 plus 0 is still 36. Square root of 36 is 6. Now we have the absolute value of negative 4i. So we have to take the square root. That is your b. There is no a, so no a means 0 squared. Plus, and then b is negative 4 squared. 0 squared is 0. Negative 4 squared is 16. 0 plus 16 is 16, so square root of 16 is 4. Now D, absolute value of 1 minus 2i. So a is 1, b is negative 2. So we have the square root of 1 squared plus negative 2 squared. 1 squared is 1. Negative 2 squared is 4. 1 plus 4 is 5. Square root of 5 is just the square root of 5. I can't break it down, so that one is done. Try these two on your own.